Welcome to today's lesson. Today we are going to continue to look at solving equations. So we have 8x plus 5 equals 23. To solve these types of equations, we're going to use the method that we see here. We first need to isolate the term that contains the variable, and then we need to isolate the variable itself. So, with the first question, we need to isolate the term that contains the variable. So I'm going to circle the term 8x. I need to isolate this term by itself. So after I do my working out, I want my next equation to be 8x equals and then a value. To isolate 8x, I need to look at what else is on that side of the equation. I have plus 5. I need to do the opposite operation to plus 5, which is subtracting 5. And because we're dealing with an equation, we need to do the same to both sides. Much like last time, I'm now just going to go through and do the calculations. 8x is going to drop down because there's nothing underneath it. Add 5, take away 5, cancel each other out completely. The equals will drop down, and 23 take away 5 gives us 18. On this line, I have successfully isolated the term that contains the variable. So now I'm at 8x equals 18. This has changed the equation into something that we already know how to deal with. So now we need to isolate the variable. So that means I'm looking to get x by itself. So I need to do the opposite operation of multiplying by 8. That means I need to divide by 8 on both sides. 8x divided by 8 is just x. The equal sign is going to drop down. And a reminder, if we can't do the division, then we can just keep it as a fraction. So 18 over 8. That fraction does simplify to give us 9 over 4. Both answers are accepted as final answers. On to the next question, which is 17 plus 3x equals 22. I start by circling the term that contains the variable. That is plus 3x. I need to isolate this positive 3x by itself. So I'm looking at 17 and I need to decide how to get rid of 17. Because this 17 was being added to 3x, I need to subtract 17 from both sides of the equation. 17 take away 17 cancels and gives me nothing. The positive 3x is going to drop down. I'm just going to write 3x here because there is no point putting a positive symbol at the very start of a term. The equal sign will drop down, and 22 take away 17 is 5. I now need to isolate the variable, so I now need to get rid of this 3. This 3 is multiplying x, so dividing both sides by 3 will cancel the 3's out, leaving me with just x. The equal sign drops down, and 5 divided by 3 can be left as 5 over 3. Our next question is 12 equals 5x take away 3. We start by isolating the term that contains the variable. So to get rid of this take away 3, we need to add 3 to both sides of the equation. 12 add 3 is 15. the equal sign will drop down, the 5x will drop down, and the minus 3 add 3 cancels. I now need to isolate the variable, which means getting rid of the 5. To get rid of this 5, we need to divide both sides of the equation by 5. 15 divided by 5 is 3. The equal sign will drop down, and 5x divided by 5 is just x. Our next question is x divided by 7 add 19 equals 36. Again, we need to isolate the term that contains the variable. This term is x divided by 7. I need to get rid of the add 19, so subtracting 19 from both sides will do this. The x divided by 7 will drop down. Positive 19 take away 19 cancels. Our equal sign drops down. And 36 take away 19 is equal to 17. I now need to isolate the variable, so I need to get x by itself. So I need to undo this division by 7, and we do that by multiplying both sides of the equation by 7. This gives us x, the equal sign will drop down, and 17 times 7 is 119. So our answer to this question is x equals 119. On to the next question, and we start by circling the term that we need to isolate. We look at the equation and decide what is the opposite operation to subtracting 5, and that is adding 5 to both sides of the equation. The 3 over 4 lots of x will drop down. Minus 5 add 5 cancel each other out. The equal sign drops down, and 23 add 5 is 28. I then need to isolate the variable, so I need to get rid of the fraction of 3 over 4. So to do that, we multiply by the reciprocal, and I need to do that to both sides. The fractions will cancel each other out, leaving us with x. The equal sign is going to drop down, and we need to do 28 times 4 over 3. The numerator will be 112, and the denominator will stay as 3. And we're going to leave our answer like that because 112 cannot be divided by 3. On to the next question, and we start again by isolating the term. So to both sides of the equation we need to subtract 7. This leaves us with the x squared dropping down. The positive 7 and the takeaway 7 cancel each other out. The equal sign drops down, and 56 take away 7 is 49. I now need to isolate the variable, so that's just going to be x. So I need to get rid of the squared symbol, and we do that by square rooting both sides of the equation. Again, that will leave us with x and equals the square root of 49 can be 7. But then hopefully we remember from our previous lessons that there's also a second solution to this equation. We can also get x is equal to -7. The next question, again, it's exactly the same method, but we're just seeing different types of equations that we can get. We want to isolate the term first, which means getting rid of +3. So we will subtract 3 from both sides of the equation. The root x will drop down. +3 take away 3 cancel each other out. The equal sign drops down, and 6 take away 3 is 3. I now need to isolate the variable, which means I'm just going to circle the x. So how do I get rid of the square root symbol? Well, we need to square both sides. So squaring root x will cancel out the root symbol to give us x equals, and 3 squared is 9. So the solution to this equation is x equals 9. On to the next question, and this is where the difficulty starts to increase a bit. I need to isolate the term, and here the minus is included inside the x term. So I need to get rid of 12 to start off with. This 12 is being added on to minus 2x, so therefore I need to subtract 12 from both sides of the equation. 12 take away 12 will cancel. The minus 2x is going to drop down. The equal sign is going to drop down. And then 7 take away 12 is minus 5. We now need to isolate the variable, which is just x. And I now have minus 2 in front of x. Now again, we need to come up with the opposite operation to cancel out this minus 2. A big mistake here is students think that the opposite operation is going to be adding 2 to both sides. This isn't x minus 2 or minus 2 add x, it's minus 2 multiplying x. So to undo that multiplication, we need to divide both sides by minus 2. Those minus 2's will cancel out, giving us x equals, and we have minus 5 divided by minus 2. Because they don't divide nicely, we can leave it as a fraction, but what we can do with this fraction is, because we have 2 negatives in the calculation, they will cancel each other out, leaving us with just 5 over 2. The next question is 7 minus x equals 2. Again, we start off by isolating the term, which is the minus x. I need to get rid of this 7. Because it's not multiplying x, it means it must be adding on to the minus x term. To undo the adding, we're going to subtract 7 from both sides. 7 take away 7 cancels. Minus x will drop down along with the equal sign, and 2 take away 7 is minus 5. Now here we have minus x equals minus 5. This is not the solution to the question because we don't have x equals. We now need to isolate the variable, which means I just want x. So I need to ask myself, how can I cancel out that minus sign? To do that, I need to multiply both sides of the equation by minus 1. Because if I do a negative times a negative, I will end up with a positive answer, and x times 1 will stay as x. So when we go through and multiply both sides, minus x times minus 1 gives us x, which is what we need for the final answer of the question. Minus 5 times minus 1 is positive 5, so our answer here is just x equals 5. On to the final question for today, and we have 10 divided by x equals 2. Now here, the term involving x is already isolated, so all I need to do is to isolate the variable. Now, we cannot isolate the variable in one step here. This is because x is on the bottom of the fraction rather than the top of the fraction. So what we need to do is we need to get x outside of the fraction. So I am looking at this divide by x term, and I need to undo that step. To undo divide by x, we are going to times by x on both sides of the equation. Notice here, it's really important that we draw our multiplication symbols differently to how we write the variable x. 10 divided by x times by x will cancel out the x variables, leaving us with just 10. But 2 times x is 2x. So now we have 10 equals 2x. This isn't the final answer, as x has not been isolated by itself. So to isolate x by itself, I now need to get rid of the multiply by 2. So we divide by 2 on both sides of the equation, leaving us with 5 equals x as the final answer to this equation. And that concludes today's lesson on equations.